Hello and good evening, CTS265 Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course from Cisco Networking Academy, and this evening's video tutorial is going to be another in our series on EIGRP. And in this tutorial, we're going to be taking a look at Cisco Learning Lab's Discovery number 4 activity, which is all about stub routing. And so we're going to be working with the branch 1A router and taking a look at the impact of turning that router into a stub router. So let's go ahead and dive in here. If I were to pull up the, let's first switch to Web Telnet. And so while this is switching to Web Telnet, one of the questions that gets asked is, well, why would I want to use stub routing? What is the use case for taking an EIGRP router and making it a stub router? And really, there are a couple of reasons. The first is you can limit the size of the query domain. Remember that when EIGRP loses a route, right, or loses reachability to a route, that it's going to generate query messages asking, hey, do you, and the you being other EIGRP speaking neighbors in the EIGRP domain or the topology, do you have a route to get to the prefix that I just lost? And so that generates query domains, and then those are sent, and they need to have a response sent back from all of the routers that are receiving them. So that can also sort of extend the amount of time required to complete convergence, because again, that route will transition into the active state, right? Okay, but again, if there's a feasible successor, and we just talked about the feasible successor, if there's a feasible successor, then there's no need for the route to go into the active state, and as a result, query messages will not be generated. So what it wants us to do first is we're going to go from privilege exec to from user exec to privilege exec, and we're going to say show IP route EIGRP. And so here are the 3 EIGRP routes that the headquarters router knows about. And you can see that it's learning all of them ultimately from the branch 1A router across this WAN link right here. And so if we get on the branch 1A router and go from user exec to privilege exec and say show IP route EIGRP, you can see that the branch 1A router is learning about a 10100 network, /16, as well as a /23 for the 192.168.16.0. Now, you can see here that this has, it's pointing to null 0, so there's a very good chance that this is a summary, and so we're going to get into that as we go along here. So on the HQ router, we're going to take a look at the output of the show IP. Let me get in the window here. Show IP EIGRP neighbors detail. And one of the things that we notice when we take a look at this output is that we have a single neighbor here, right? It was the first neighbor that was learned. There's our H column. And there is the neighbor, 172.16.1.2. We know about that neighbor out our Ethernet 00 interface. Again, it's quicker than, it's a non-NBMA network. It's quicker than and it's quicker than a T1 speed. And so we've got a hello time of 5 seconds and a hold time of 15. You can see things have been up for 3 minutes and 42 seconds. And we've got our SRT and RTOs. And we can see the version, the version of EIGRP that's being run here. Now, the reason we need to know about this command is when we start to deal with EIGRP stubs, we're going to see some output down here toward the bottom that's going to indicate with respect to the peering, right, the neighbor adjacency that we have, as to whether or not it's a stub, and if it is a stub peering, or if the peer is a stub, then it's going to tell us whether or not, or what routing information we would expect to receive from that stub. Would it be connected? Would it be summary? Would it be receive only, right? So the stub is not advertising any network. It is only going to be receiving information from that HQ router. So on the HQ router, we're going to kick off some debugs here. So we're going to say debug EIGRP packets terse, and that's going to give us a little more verbose output. And now let's go into the interface loopback, and actually let's get into global config here. and interface loopback 0, and we're going to shut that interface down. And this should obviously generate some EIGRP messages. And you can see what's the very first message that is getting, and I apologize, I've had ink to go goes in the background and then won't come into the foreground until we quit and restart. So the very first message we see, and the one that we're most interested in right here, is sending query, right? So the HQ router has lost reachability, right, via EIGRP to that interface, and so it's going to send a query out the Ethernet 00 interface. And is that a reliably sent message? Is a query reliably sent? And we know that it is because we see a sequence number indicated in the debugs here. And it's sending that query out, basically saying, hey, does anybody else have a path to get there? And you can see we get an acknowledgement back right away from branch 1A. And then we've got received a reply here from branch 1A. And you can see the sequence numbers, right? And those all match up. And then we get an acknowledgement that it's been withdrawn, or we're in queuing an acknowledgement here that it's been withdrawn, right? Because we've shut the interface down. And so that is how the query message flow goes, is that the router loses visibility for an EIGRP learned route, and then it's going to generate a query message. And so that is what we're talking about, limiting the size of the query domain. And when we look at the drawing, and from a topology perspective here, you can see that if branch 1A, and this is going to be the router that we declare to be the stub, right, is declared a stub, branch 1A only has a single path out of the network to get to these HQ networks over here, right? So branch 1A really doesn't need to receive a ton of routing information, and it really doesn't need to advertise a whole lot of routing information. You can see we've got some networks that are back here, but again, it only has one path out of the network, and there is our summary right there. So it looks like we're receiving a summary. I haven't checked this yet. Looks like we're receiving a summary from branch 1B. All right. So when we talk about the stub options, you've got connected, right? That's going to advertise connected routes. You've got summary, which is going to advertise configured summary routes. And those are the two defaults. So if I were to simply go in and say EIGRP stub and turn branch 1A into a stub, by default, the two options for the stub would be connected and summary. You can also do static. You can do redistribute, you can do receive only. We can even do a leak map, which is something we'll get into probably in the odds and ends video at the end of this section. Okay, so now let's go ahead. We're going to bring that interface back up, right? Because we wanted to see the query that gets sent. And that's the key. If I make this a stub, this peering right here is going to reset. And when branch 1A says to HQ, hey, I'm an EIGRP stub, HQ says, well, in that case, I don't need to send you a query because I already know that you have no way to get to the network, that loopback 0 network that I just shut down, or for that matter, any of the other networks that are over here. I mean, we could have 172.16s, we could have whatever we want, right? You could have 10.2.0.0/24. You know, so there could be hundreds of networks over here behind HQ. And if those networks go down, right, and HQ is generating queries and sending queries over here to branch 1A, that doesn't make any sense because we already know from the topology that we're looking at right here, can branch 1A, does branch 1A have some secret backdoor into the HQ networks? No. It doesn't. And so if branch 1A doesn't have a secret backdoor path to get into those HQ networks and can only go this way, HQ already knows I don't need to send all these query messages this direction because branch 1A, I already know branch 1A has no other way to get there. So why would I waste the processing time? Why would I expand the query domain? Because HQ has to query the branch. The branch is then going to forward the query over here to branch 1B. And those were the additional messages that you saw when we were doing the debug. And then branch 1B has to respond back to branch 1A and say, nope, I don't know how to get to the network that HQ lost. And then branch 1A comes back and sends it over to HQ and says, nope, we don't have another path. We don't know how to get there. And again, it's already predetermined based off of the layout here that that's the case. So why would we not make branch 1A a stub? It makes complete sense. And again, that limits the query domain, because as soon as branch 1A becomes a stub, at that point, that stub router, when it negotiates, but it reestablishes its peering with the HQ router, and we do that show IP EIGRP neighbors detail, we're going to see that HQ recognizes the fact, and it will say suppressing queries. Because at that point, when branch 1A says, I'm a stub to HQ, HQ says, well, then I'm not going to send you any queries because I know that if I do, it's going to be meaningless. Because you'll never know how to get to the networks that I have over here. You don't have another way to get there. All right, so let's get back into the HQ router here, and we're going to say no shut. So we're going to bring do show IP interface brief. Yeah, that's at 10.1 network. So we're going to bring that interface back up, and you can see when we bring it up, it's not queries that get sent, it's updates that get sent. Because remember, it's now sending update messages out saying, hey, I'm advertising this network via EIGRP. Okay, so let's kill those debugs with a do you all, or do undebug all is what that actually stands for. And we've already done the show IP EIGRP neighbors, but what we're going to do now is we're going to go on to branch 1A, and we're going to kick in that stub functionality. So let's go into global config. We're going to say router EIGRP1, and literally it's simply EIGRP stub. Now, we've got a lot of options here, and there's that leak map option that I had referred to earlier. And that's if we wanted to specifically leak out an individual prefix that might be part of a larger summary. And by default, if I just hit enter, you see it's going to tear down the adjacency. And there you go. It has to, because it's exchanging messages right now with the HQ router. And it's telling the HQ router, hey, I am now, do show IP EIGRP neighbors detail, I am now a stub, and as a stub, branch 1A is telling HQ, go ahead, suppress queries to me, because I'm not going to know how to get to any networks that you could possibly be asking me about anyway. In fact, you can see that what is the stub peer advertising? Only connected routes and only summary routes, and that's by default. So connected and summary, if I just type in EIGRP stub, those are the only two types of routes that the stub router is going to advertise. And remember, we are limiting the scope and size of the query domain because the HQ router, now when it loses that 10.1, whatever that was, the 10.1.1 whatever, when it loses, or 10.1.0.0.16, when it loses that network, right, it is not going to generate a query message over to the branch 1A router. And so let's see what that looks like. So on the branch 1A router, if we were to say, let's say debug EIGRP packets terse, right? And now let's come over here to the HQ router. Let's get back in. I think we're in that interface already. Loop back 0, and let's say shut. And we'll come over here to branch 1A. Now, the query that you see here, right, it's not sending a query looking for it. It's basically sending a query because it's withdrawing the route. That is what this query is for. The query here is simply, hey, I'm withdrawing that prefix from my routing table. And that's what's happening. You can see it's not receiving the query, it is sending the query, right? So it's sending the query because it's saying, hey, I'm pulling this route out of my routing table because I've received, the information that it's been removed. It's no longer reachable. And so that's the message that is being received, right? So that's the message that's being received. All right. So let's go ahead and clear the screen there, and let me take a quick break here. Hold on just 1 second. Sorry about that. Phone interrupting us. So again, that's the query that it is sending on the Ethernet 00 interface, is basically that it is removing that network. All right, so that's branch 1A, and it's still advertising connected and summary route. So on branch 1A, if I were to say show IP route EIGRP, you can see that there's our summary, but we did lose some of those other routes, right? Initially, we had more routes than that in the routing table. Let's see what HQ shows in its routing table right now. So do show IP route EIGRP. And again, that is all that is being received is the 192.168.00/24 and the summary route that we know about, that 192.168.16.0/23. And the 192.168, if I were to say do show IP interface brief, and actually, if we look at the diagram, where is that? Here it is, right here. It's that loopback address here, right, which is considered connected. And then here's that summary route. And we see the summary on branch 1A, right? We don't see it when we say show IP route EIGRP because this is a directly connected network, but it is being advertised out. So the two things that are being advertised out are the summary right here. And actually, that summary shows for the 16 and the 17. I don't believe it shows for the 18. And let's take a look at that actually. So if we were to look here and say show IP interface brief, and how about a show run section EIGRP? And so it doesn't appear. Show run interface, let's do Ethernet 01. Oops, show run interface Ethernet 01. All right, so it's just got that 16, but we are getting that /23 in. And let me make sure. Let's see what we have here. Show run section EIGRP. And what about a show run interface Ethernet 00, where we have our summary address would be. Yeah, so we are showing the 16 as a /23, which I believe would be the 16 and the 17 /24s, but not the 18. So yeah, I have to take a look at that. And that's interesting that it shows the directly connected network is being summarized along with the 17, and I don't believe the 18 is. And they're not running EIGRP over here. It doesn't appear. So, but we are advertising the summary for that because we do know how to get to the 16 anyway. All right, well, let's continue on here, and we may run into that in a second here. So we're on step 8 where we took a look at the show IP route command where we see the /24 for the 192.168.0.0, which is that network here, loopback 0, and then we see the 16/23, which is the summary that we're advertising. So on step 9, what we're going to do on the branch 1A routers, now we're going to change. We're going to go into global config and say router EIGRP1. And now what we're going to do is we're going to kind of tweak the stub setup. So by default, it's connected in summary. So now what we're going to say is EIGRP stub connected. Now again, this is not something you want to do in the middle of the production day because as you can see, it's going to tear the adjacency down and it's going to then build the adjacency back up. So while that's happening, you've lost connectivity and you've lost that peering. So we're only advertising connected routes. So if I come back over to router 1 and say do show IP, or I'm sorry, HQ, EIGRP neighbors terse, do show IP EIGRP neighbors, or not neighbors terse, sorry, neighbors detail. You can see that it changes here, that stub peer advertising connected routes. And again, suppressing queries, because HQ has no need to send a query over to branch 1A. It already knows that branch 1A is not going to have an alternate path to get to any of the routes that the HQ router might end up looking for. And so now on the HQ router, if we were to say do show IP route EIGRP, you can see we are seeing the directly connected, which is the loopback 192.168.00/24. And we actually still see we don't see the summary. Okay, yeah. So you'll notice we're not seeing the summary. I thought that was the /23. What are we seeing? We are actually seeing the 192.168.16.0/24. So we're seeing this transit segment right here. Because again, that is directly connected. This is directly connected. We don't see these because, well, for one, we were summarizing, right, in order to provide reachability to the 17 and the 18, but they're gone because we're only doing connected, right? We're only doing connected at this point. So again, and it would be the same if I were to go back over here and we could flip it to the other way, right? Where I say EIGRP stub and summary only. So again, it's going to tear down the adjacency, but if I come to the HQ router and I say do show IP, not route EIGRP, but neighbor detail, you can see now that it's only learning. The stub here is only advertising summary. So do show IP route EIGRP, what is the only thing we see, right? We no longer see those directly connected routes. We only see the summary. And so that's how you can manipulate how the stub is set up. And so let's do one final change on the stub where we're going to say EIGRP stub receive only, which means that the stub is not going to advertise any information. Look, no EIGRP learned information on the HQ router, right? Because it is only the stub, branch 1A, is basically telling HQ, hey, I am only interested in receiving routing information, but it's still a stub, so it is not going to, and I'm sorry, I want to get on the HQ router to see neighbor detail. You can see right here, receive only peer advertising no routes, and we are still suppressing queries. Again, limiting the size of the query domain. With what we have, again, these are introductory activities that try to drive home the concept in a very inductive type of approach. But when you get into a real environment where you have 200, 300, 400 routers running EIGRP, limiting the scope of your query domain, because remember, a route will go active until the router has received back acknowledgments to all of the query packets that are getting sent out, asking, hey, does anybody know? And then it propagates out all the way throughout your EIGRP domain. And you're not going to have that route go into a passive state, right, or be withdrawn until all the responses for all of the queries are received. And so that's why it's so critical to limit the size of the query domain in EIGRP. But again, with 3 routers in this example here, it's kind of like, okay, I mean, do we really need to limit the query domain? Well, not really, but again, it's to try to drive home the concept that when you get into larger environments, yes, you will need to figure out, hey, how could we possibly limit the scope of the query domain? And this is one way to do it. All right. So that is going to wrap up the activity here, discovery activity number 4 on stub routing. You'll see more of this in the odds and ends video that I'm going to be doing up once we complete this section. We're going to take a look at the leak map, and we're going to look at some other output. And actually, before we go, let's do this. So router 8 and router 9, who are still running EIGRP, let's kick off a packet capture here. And let's see, it's always nice to get a look at what it looks like from the perspective of these routers here, because we can do a Wireshark packet capture. Show IP interface brief, and the loopback 9.9.9.9. So let's do this. We'll go into, we may have to do it from router 8 side. And we're going to say interface, and I think we already have, do show IP interface brief. So we're going to say interface loopback 8. IP address is going to be 8.8.8.8. Whoops. And we'll make it a /32. And we're going to make router 8 is going to be sort of the pseudo HQ router. Now, if I were to come over here to router 9, and hopefully it's, there we go, it's all done, show IP route EIGRP. So we should see we have an EIGRP learned route here, right? So we're doing a debug. If I remove the route, and we're going to pretend as if this is the HQ router, right? We're not debugging. We're doing a packet capture. I say shut. We pull Wireshark back up, and whoops, sorry, and we probably want to get all the way down here to the recent activity. And so I said shut on router 8 and take a look. There's your query message. So let's do a little deeper dive here into the query message. You can see Cisco EIGRP version 2. The operational code for the message is a query message, right? Opcode value 3. Checksum was correct. The flags are out. So there is your sequence number, right? Remember, this query is a reliably sent message. It is going to expect an acknowledgement back. So virtual router ID, right, it's just 0. Our autonomous system is 0. And there is the there is the information. And again, this is multi-topology routing. This is something that really never caught on, and so we're going to go past that. And you can see we've got the legacy metric and the information for the 8.8.8.8. Again, asking, that query is asking, it's being sent out here, multicast. It's going to be picked up by router 9, and you can see that 9 is now responding back to router 8, because 8 is basically firing it out there via multicast to any EIGRP speakers that can reach on the wire, saying, hey, I just lost reachability to the 8.8.8.8. Do you have a way to get there? Do you have an alternate path so that I can come through you now to get there? And when we take a look, here is the acknowledgement, right? And what was the sequence number of the query? 6. The acknowledgement here is 6. So this is acknowledging in the hello packet that no, we don't have a way to get there, right? So it's acknowledging that it has no way to get there. And then 9 is going to reply as well. And you can see here. And what's happening is when 9, sorry, let me get back down here. There we go. When 9 is replying out saying, yeah, I can't get there and I'm pulling it as well, right? So it's dropping it, and then you can see we have an acknowledgement from 8 to 9, and there's your acknowledgement. It's an acknowledgement of sequence number 6 that was being sent back and forth between these two speakers. And so that's exactly what happens when we look at the query that gets sent out. And again, this would cascade to all of the EIGRP speakers in the domain until responses have been received for all of those query messages. All right, so that's going to wrap up discovery number 4. And in discovery number 5, I can't remember what we're going to be looking at. It's going to be some more EIGRP. All right, well, have a great evening, and I will see you guys tomorrow night at 6 o'clock.